Hey friends, so today is our last lesson on systems of equations and inequalities, okay? And we're going to take a look at quadratic inequalities of two variables. So just a quick recap, 2 lessons ago, we looked at linear inequalities of two variables where we had like y is greater than 2x plus 3, okay? And then what we did there was, because I said y is greater than 2x plus 3, and it didn't say equals, we would have a dotted line. So I would draw the line y equals 2x plus 3 as a dotted line, and then I would shade above it because I said greater than, okay? Today's very similar to that, okay? Except we're dealing with quadratics. So if I can be equal to, my parabola is going to be solid. And if I can't be equal to, if I'm just less than, or if I'm just greater than without the equal to sign, my parabola will be dotted, okay? Then, just like with the linear inequalities, if I'm greater than, I want to go along my curve, go along my parabola, and shade above. So think about what area would happen if I shaded arrows above the parabola, or what would happen if I shaded arrows below the parabola going down for less than, okay? So if you look at the example I gave you just on this opening picture, this is shading above, and we can see if I just put on some ink here, I'm shading from that line, I'm always going up, okay? Whereas this guy, so that's the greater than, see that? Whereas this guy is shading below, from that line, I'm always shading below, okay? And that one was the less than, okay? So that's what we're gonna tackle today. We're also going to review how to draw these things by hand. So that'll be an excellent, excellent review for everybody as well, okay? So for our first example, we are going to take a look at graphing the parabola y equals x squared minus 2x minus 3, label the x-intercepts, the y-intercept, and the vertex. Now, we are going to review how to get all of these algebraically, okay? When it says to label, you can either put the coordinate point directly on your graph, if you can do that neatly enough, or put a big dot where those important points are, and then just make sure you've listed the important points off to the side. So I'm going to actually calculate all the important points off to the side right now. Okay, first one being the y-intercept. I know the y-intercept right away, it's at -3, right? Because that's the constant term in general form. Okay, so I know my y-intercept is at 0, -3, and I'm going to go ahead and plot that. So 0, -3, I've got that there. The next thing I want to do is the x-intercepts. I know that when I go for the x-intercepts, I'm going to set y equal to 0, and I'm going to try and factor it, okay? So if I go to try and factor it, x squared minus 2x minus 3 factors into x minus 3 and x plus 1, okay? And that gives me the zero product principle. I know that x equals 3 or x equals -1, okay? So I can go ahead and plot those guys. -1, 0, and 3, 0, right there and right there, okay? Now I want the vertex. So to get the vertex, I know that the x value of my vertex has to happen halfway between the two x-intercepts. So I'm going to take the average of the two x-intercepts. So -1 plus 3 divided by 2. -1 plus 3 is 2. 2 divided by 2 is 1. So I know the x value of my vertex is at 1. So now what I'll do is I'll take that 1 and plug it in for x and get out the y value. So 1 squared minus 2 times 1 minus 3. I'm just plugging it back into my original equation. Okay, and that's going to give me y equals -4. So I know the vertex is at 1, -4. Okay, and now I can plot that guy as well. I can have one more point that I can plot here, just dealing with the symmetry, right? If the y-intercept is 1 away from the vertex here, I can go 1 more on the other side because of the symmetrical aspect of a parabola. I couldn't quite think of that word. Because of the symmetrical aspect of the parabola, I can put another dot right there. Okay, and so now I've got a fair amount of dots here that I can accurately draw my parabola. Okay, all right, let's try another one. we're going to graph y equals negative 2x squared minus 5x plus 3. Again, we're going to label the x-intercepts, the y-intercepts, and the vertex, okay? So I'm going to walk you through the exact same process. I know my y-intercept first. My y-intercept's at 0, 3 because it's the constant term, okay? So I can go ahead and plot that guy. Now, the x-intercepts, again, I'm going to let 0 be y, or y be 0, I should say, and I'm going to try and factor it. You can factor this however you like, whether you use, I want you to notice, not only did I let 0 be y here, I also multiplied everything by -1, okay? I don't like to deal with that negative coefficient at the front, so I just switched all the signs. I'm allowed to do that because I'm multiplying by -1 to both sides. It just happens to be that 0 times -1 is still 0, okay? So that was an allowable algebraic move. I haven't changed the equality statement by doing that, okay? Now I need to factor this. If you use decomposition, if you use cross product method, whatever you like to do, if you use inspection, go ahead. I don't care how you get to the next line, but the factored form should be 2x minus 1 times x plus 3, okay? Now, if that's the factored form, that's the zero product principle. So I know that I can go x is 1/2 and x is -3, okay? Little typo there, you can take out that negative. And so my 2 points would be -3, 0 and 1/2, 0. So I'm going to go ahead and plot those guys. Okay, now this guy's a little trickier when I go to get the vertex, just because I'm taking the average of a number and it involves a fraction. So that's going to get a little bit messier, but we can totally handle that. So I'm going to end up with -3 plus 1/2 all over 2. Okay, -3 plus 1/2 is essentially -2.5, and -2.5 over 2 is -5 over 4. Okay, so now I'm going to take my -5 over 4. I'm going to plug it in as x into the original equation and get out my y values. Okay, when I do that, I end up with 49 over 8, okay, which is 6.125. This one's a little messier as far as graphing goes. If we asked you to graph on a test, we would give you friendlier numbers to do, okay? So 49 over 8, roughly 6.125. So that is what I'm going to graph for the vertex, -5 over 4 and 49 over 8, which is right about there, okay? Again, just like in the other example, once I have the vertex, I'm also going to get one more of these points just from symmetry, okay? Now, I know the vertex is a little hard to read there, so I'm going to base it with my x-intercepts. I'm half away from that x-intercept, so I can go to this -3, go half in and up, and I can get another point right there, okay? And now I have enough points that I could draw an accurate sketch of my parabola, okay? Awesome. All right, so solving quadratic inequalities. A quadratic inequality in 2 variables may be in one of the following forms. And again, this is where a, b, and c are real numbers and a can't be 0. So either we say y is less than or equal to the parabola, y is greater than or equal to the parabola, y is less than, or y is greater than, okay? And just like I said at the beginning, if it equals, it would be a solid line or a solid curve. If it can't equal, it would be a dotted curve, okay? And then if I'm shading greater than, I think about arrows going up from the curve. If I'm shading less than, I think about arrows going down from the curve, okay? A quadratic inequality in 2 variables represents a region of the Cartesian plane with a parabola as the boundary. The graph of the quadratic inequality is the set of points x, y that are solutions to the inequality. So just like we could look for test points in linear inequalities, we can do the same thing in quadratic inequalities, okay? So graph y is greater than x squared minus 2x minus 3, and determine if 2, 1 is a solution to the inequality. Now, you've actually already graphed that one by hand. That was our first example. Now I'd like you to throw it in your graphing calculator, okay? You can verify with your graphing calculator that your hand drawing one is accurate, okay? Of course, you can pause me and get that set up. This is the picture you should be looking at. And again, greater than, so you can see I have a dotted line, okay? And greater than is always shading above, okay? Now, we were asked to determine if 2, 1 was a solution. So that's my test point, 2, 1. I'm gonna plug 2 in for X, 1 in for Y, and see if I get a true statement, okay? So I plugged 1 in for Y, I plugged 2 in for my X. I end up with a statement that reads 1 is greater than -3. Is that true? Yes, it is. Okay, so that means that 2, 1 is a solution to the inequality. Okay. Okay, we'll try another one. Y is less than or equal to -2x squared minus 5x plus 3. And again, we're going to look at that point 2, 1 and see if it's a solution to this inequality. Again, this is the second one we just graphed by hand. Now you can go ahead and graph by technology. Pause me and get your picture ready so that we can compare. Here's what my picture looks like. Okay. Okay, so we're going to do our test point of 2, 1. I plug in 2 for X, 1 for Y, -2 times 2 squared minus 5 times 2 plus 3. I end up with a statement that reads 1 is less than or equal to -15. That is not a true statement. So that point, 2, 1, is not within the solution region. Okay, 2, 1 is not a solution to the inequality. And then if I was looking at it on the graph, 2, 1 is like right here, right? We can see that that's not part of that shaded region. Okay. Awesome. Okay, let's try a little word problem. A satellite dish is 60 centimeters in diameter and 20 centimeters deep. The dish has a parabolic cross-section. Place the vertex of the parabolic cross-section at the origin and sketch the parabola that represents the dish. Determine an inequality that shows the region from which the dish can receive a signal. Okay. All right, so we have a satellite dish, something like that. Okay, now what we're going to do, if you think about this, if I was to cut this in half, my cross-section would essentially look like that. Okay, so that's that parabolic shape that we're talking about. And anything actually within that parabola, any signal coming in will actually be able to come into the satellite and get picked up by the satellite. Okay, so I'm going to call the origin right here at the vertex of the cross section. Okay, so if I place an X and a Y axis on top there, then I can kind of draw in my cross section of my parabola. Okay, now it's 60 centimeters in diameter. So from here to here is 60 centimeters. I also know that it's 20 centimeters deep. So if I needed to get a friendly point here, I could use a point right there. And I would say, okay, well, if that 0 from here to here has to be half of that 60. So I know that my X value would have to be 30 there. And then the fact that it's 20 centimeters deep, that's going to give me my height. So I could actually put a point right here and call that point 30, 20. Okay, again, it's because it would be half of the diameter, and then it's 20 centimeters deep. So from the top to the bottom would be 20 centimeters. That's where I'm getting that point 30, 20. Okay, so now I need to build an equation so that I can then figure out an inequality, right? My inequality is actually going to be y is greater than whatever my equation is, right? Because it's everything in here that will receive the signal. Okay. Okay, so we're going to use y equals a x minus pl squared plus q. My p and q are 0 here. And then I'll use my 30 and my 20 as a friendly x and y value so I can solve for a. Okay, so 30 minus 0 is 30. 30 squared is 900. So I'm looking at 20 equals 900a. Okay, so a ends up being 20 over 900. And that can be reduced to 2 over 90, which are then further reduced to 1 over 45. Okay, so a is going to be 1 over 45. So my equation, again, I'll be looking at greater than, right? Everything with an arrow going above this parabola. So my equation is going to be y is greater than or equal to 1 over 45 x squared. Okay, y is greater than or equal to 1 over 45 x squared. Okay, so now I've just shown you a computer-generated version of the same thing. Okay, right here. Okay, I went up a little higher just so you could see kind of the parabola that's happening, but you can see right here, here's the point 30, 20, like we had started. Okay, so I just took it a little higher in my computer-generated version. All right. All right, good job. Your mission, should you choose to accept it, and you have to, is written here. Enjoy it. Make sure you're practicing lots, right? The more you can practice, the better you're going to feel about this. I get that this is a really stressful course, okay? You taking the initiative to practice as much as possible is actually going to help you bring your stress level down because the questions will start feeling more familiar, okay? That's the key to homework. It helps the familiarity. Okay, make sure you connect with me if you do have any questions, and we'll see each other soon for our next unit. Take care, guys.